But for
Okay.
now, we're recording it. And you may have noticed, because we've done a lot of assignments already, using the QC in the chapter in our textbook. And we've also done the QC with the ACR digital mammography manual. So you've had a lot of assignments on QC, and I know it jumps back and forth between 2016 and 2018, which is confusing. But basically, the newest version of the manual that we've been kind of looking through that I uploaded digitally, that is 2018 now, but that's only because the digital breast tomosynthesis was added to it later. So if anything says
Okay.
2016, which our textbook still says 2016, because the new manual came out after our textbook was copied. So it kind of goes back and forth, but it's the same thing. 2018 just means that DBT was added later. So
Okay.
if it jumps back and forth, just don't let that confuse you. Okay, so quality control, it's the part of the quality assurance program, and it focuses on the instrumentation and the equipment technical performance and the reliability to ensure that quality and accuracy of the mammographic image and the safety of the patient. And that was actually one of your review questions, I believe, in module 3,
Yeah.
coming straight from the textbook. Um, so that's just kind of the definition of QC. And we know that the responsibilities are by the medical physicist, which you see a lot as just listed as NP, the lead interpreting physician, which is your radiologist, and you see that a lot in the QC manual as LIP, and then the mammography QC technologist, which is us, and then sometimes it just refers to us as the rad tech. So the radiology technologist or the mammographer, all of that will just be, basically the same. It's just related to our responsibilities as the technologist. So in Memo 102, I just kind of broke down that in Module 3, we worked on Chapter 10, which was straight from your textbook, and then you already did the review questions, the quiz, the discussion board, and the tests, and you did great on those. And then Module 4, you also did great on those. I just graded those this morning, so you probably haven't even seen those grades yet. But that's where we focused on the QC manual. And then you had some review questions, a quiz, and that was the discussion board on whether you think one technologist should do everything, or whether you think more than one should be able to do the QC. And then
Right.
as we go through this testing, we'll kind of see why it's kind of subjective. So sometimes it is good just to have one person, just because you may see something different. Sometimes when you're in X-ray, you're saying, hey, I need a second pair of eyes. So it's sort of like that. Everybody has their own subjective, the way they see things and the way they view things. So, and then in Module 5, we are just focusing on the radiologic technology section of this manual, which is all this QC testing that we will have to do in the clinical setting. And then I will also, don't let me forget to show you some clinical documentation before we get off of here, because I've got it all laid out of what you'll need to do once you go to clinic. So we'll do that kind of at the end. So our responsibilities are ongoing, and then we have weekly tests, and then we have quarterly tests, and we'll go through all of these. So the QC technology tests, these are what we are responsible for. I don't know if it's in your way, but it's not moving. Okay. So we do the phantom image quality, and that's the one I'm going to focus on most today. That's the one that we focus most on this assignment that you're about to take, and it's also one that you'll do the most in the clinical setting, because you will have to do 10 phantom image quality tests while you're in clinic for the ART requirements. So that's the main one we'll focus on today. We also do the compression thickness indicator, a visual checklist, an acquisition workstation monitor, which is our monitors, and the radiologist workstation monitor. We'll talk about a repeat analysis, viewing conditions, compression force, and the manufacturer detector calibration. All right, so the one that I told you we're going to focus on the most, the image quality phantom test. We perform that weekly, and it's performed by us, the technologist. We have to do that, like I say, once a week. We also have to do it anytime that the machine gets worked on. We have to do the phantom test before we can image any patients. And then, of course, upon installing any new equipment, we also have to do that test. So that's just to prepare us, let us know that we are ready to see the bare minimum in that breast. You know, in case something's hiding under all that breast density and everything, we have to make sure that we can image the tiniest little calcification on our images. So it's to verify the quality and the consistency of the image and ensure that we don't see any artifacts that could be confusing and mistaken for, you know, a real calcification or mass or anything. We do this test with the ACR phantom or the manufacturer's phantom, and we'll talk about the difference in both of those. The phantom is equivalent to 4.2 centimeters, which is the average compressed breast is about 4.2 centimeters. Now that's based on average, based on tiny little breasts and also, you know, giant breasts. So 4.2 is just the average size that we go with. And then a 50-50 breast, meaning 50% glandular density and then 50% of that adipose, that darker, you know, soft tissue.
Okay.
So we evaluate the phantom on the acquisition workstation, the acquisition workstation being ours, just our monitors, and we look for artifacts. Between the traditional or the new digital, the traditional it's that square one, and it has 6 fibers, 5 spec groups, and each spec group has 6 little dots that are the specs, and then 5 masses. So all of this is, you know, sort of, it's sort of like the equivalent of the density in an actual breast. So your spec groups would be like little calcifications, your masses would be obviously like big masses, and then your fibers would be all that extra little dense, all the, you know, all the fibers and the Cooper's ligaments and all those things that we learn about in anatomy. Can't move this little. Okay. And then the 2018, the new ACR digital mammography phantom. Personally, I have never used that in any of the facilities that I've worked in. It's that longer rectangular one, which I don't even have a copy of, but I do have a picture on here for you to see. And it has 6 fibers, 6 spec groups, again with the same amount of specs, 6, and then it has 6 masses. So they look like this. So you have your traditional ACR phantom, that's the square one that has the 6 fibers, spec groups, and what am I missing? Masses. And then the traditional phantom, all of them go straight across, and it has 6 of each. So when you do your test, so the important thing here is when you sit for the registry, you really do need to know the purpose of all of these tests, the frequency of all of these tests, whether it's weekly, whether it's quarterly, whether it's annually, all that stuff. And then know the equipment that you need to use to complete each test, which is why I'm telling you about this paddle and everything. And then you'll obviously need to know the step-by-step procedures. So the step-by-step procedures is kind of why most people stick with that traditional phantom instead of switching up to the manufacturer's phantom. Because if you have like a Hologic machine in one room and then you've got like GE in another, then you're switching back and forth between different phantoms, and then you're also switching back and forth between different manuals. So there could be a different step-by-step procedure. So
so most places use the phantom test.
Yes. So I've always used, I don't know if you can see my pointer here, but I've always used this traditional one. That way you can use that same one on every machine, no matter what. Whereas if you switch to the ACR
the new one,
yes, if you switch to this longer rectangular one, then that means you're using a different manual that came with each manufacturer's machine. So there would be different processes. It will look different. And then subjectively, you may not be able to see the same thing on each monitor, if that makes sense.
Right.
So, okay, so you use the largest paddle, and the type of paddle can be flexed or fixed. Most people use the fixed. A lot of people don't even have, or I should say facilities rather than people, a lot of facilities don't even use the flexed one so much. But you can use either one of those, and it is the larger paddle. So there are like little mini paddles that are used for smaller breasts. There are magnification paddles and spot compression paddles and everything. But you'll learn all of those paddles as well when you go to the clinical setting. But just know that you do use the largest for your phantom image test.
Because I'm not a big learner when I have to teach myself or how this first semester's been. I'm actually ready to go to clinicals because I'm a hands-on person.
Good. Well, you'll be awesome. You'll be ready. And if you ever want to come here, I don't know if I told you this, but we do have a lab on site. It doesn't work for imaging because it is just older, and it's just here basically for you to just kind of get some hands-on.
Right, until I get hands-on.
Just to see if, just so that some people just feel more comfortable when they go to clinic, knowing that they have actually touched a machine, seen a machine, and kind of know what everybody's talking about when they say, grab that paddle. At least you'll know, which one to grab or whatever. But I know you live out of town, so that's completely up to you. But if you ever want to schedule something with me to come and, kind of play with our machine in here, that's absolutely fine. We have all the paddles and, all that stuff.
I actually did clinicals at SRA, the Southeastern Radiology Associates, when I was in X-ray school. So I've seen a few mammograms there as a student with X-ray.
Yeah, and we've got I've got to remind, you haven't already set up a schedule for your clinicals, have you?
No, ma'am.
Okay, so what you'll do is just let me know whenever you get a chance. Just kind of give me a schedule of when you believe you can do clinicals, and then I'll get with Christy over, because you're going there again, right? You're going to Lumberton.
Yes, ma'am.
Right. Okay. I've got 3 new students coming in the fall, and they've all been telling me where they're going. So I just want to make sure I've got my stuff straight in my brain. So you're Lumberton. So I'll get with Christy once you let me know your schedule, and see if she can accommodate you on those days. And also, most facilities only do their QC testing 1 time per week. So you may, depending on when their schedule is, most of them are like first thing Monday morning, they do their QC. So if you're not available first thing Monday morning, then we have to kind of make other arrangements to find you where you can do your QC.
I should be able to go whenever, because that's another reason why I stayed PRN with my job, because my little girl, she's 1 year old, and I when I had her, I actually stepped down because I was a full-time tech with X-ray, but whenever I had her, I stepped down to PRN. So, and I knew I was coming back to school, so I just stayed PRN.
Okay, so I tell you what, I will send I'll just kind of copy you both in an email and just kind of introduce you to each other in that email and just say, hey, when do you do your QC? Ask Christy, when is your QC done? And so that we'll know if Lauren is available on those times, and then we'll just kind of get your schedule set. Because I don't know if you want to do, because you could go 5 mornings for 3 little hours, or you can do 2 7.5-hour days and just knock it out, just get your 15 hours a week. But we can work on that and getting your schedule set. But you will need to be available 10 different QC days whenever they do their QC.
Okay.
Now, if worst comes to worst and you can't be in clinic on the days that they are scheduled for their QC, then we can either put you at another facility for their QC days, or
because where I work at in Wyville, they have mammography there. They do mammograms there too.
Okay, so maybe they would even let you, but I don't know. We haven't worked with, because you work with Columbia, Columbus, what is it called? Columbus Regional, Columbus.
Yes, ma'am.
Yeah. So we don't have an affiliation agreement with them that I'm aware of. Or do we? Either way, it would be it would require just some paperwork to be done if we needed to send you there. But
Okay.
but that's all fine too. We can that's something we can just make that happen. It's fine. Um, but anyways, if worse comes to worse and you can't make their schedule, then we also can possibly just let you do it like after hours or whatever, if Christy will allow it, and they just won't put it in their actual books. So it'll count for you that you've got the experience, but it won't be their actual scheduled QC date. So it would be not simulating, you'll actually do it, but they just won't record it in there like as their QC, if that makes sense.
Okay.
So we can work around with your scheduling and get it done. Okay, so this is what these phantoms look like in the clinical environment. So if you see that first image, again, is the traditional. Second image is that one that would come with the manufacturer. But you line it up towards the chest wall border. So of course you don't put it up against. Let me see if I can get my pencil here to work, if I even know how. I don't. Can you see my mouse though?
Yeah.
Okay, good. So right here is what's along the chest wall. So your patient is here, breast is, right here where this phantom is. So this is the chest wall. And then on this image, obviously this is a chest wall. So you wouldn't take this phantom and put it way in here and do the images. You would do it right here where a breast would be. Now, that's not to say that
Okay.
everybody would be that size, but like I said, this is the average size breast is what this is, supposed to be um, mimicking. So that's what it looks like in the clinical setting. And then here's what it looks like on an image. So once we take that image, now is when we say, okay, what do I see? All of our monitors are going to be the same. Matter of fact, I have two monitors that I'm looking at right now. If I pull these images over to the opposite monitor, sometimes I don't even see the same number of specs that I do on my other. So that's why I say it's very subjective at times. So when you do take this QC testing assignment, you may see something different than I see, but I'm going to look through that. So don't worry about your grade if it automatically grades you at something, because I'm going to look at it later and I'm going to justify, okay, her monitor must not show all 6, specs in their group, whereas, mine might. So I'll kind of grade it based on, justifying that you may see something just a little bit different from mine. So on this first one, if I could make this bigger, I probably could see more. There it is. So I see a fiber here, and then I see a fiber here, and I see a fiber here, and I think I see a little of one here. I don't know if you see it on or not.
I do.
But then there are 2 more down here that I do not see. But anyways, I would count this as 1, 2, 3, and probably a half. So that would get 3.5 points on this image. And then we've got some specs, and I can barely see the specs on mine. I can see 1, 2, 3, 4, 5. There should be one over here that I really can't see. And then I can see some down here, but I can't count them because, and we'll talk about that later. But anyways, this is what they look like on an image. And if that was the only thing that I saw, then this wouldn't pass. But it's just because it's on a PowerPoint. It's probably been copied over a million times. And, plus I'm trying to show you on 2 different monitors. And so that wouldn't pass if I could only see those 5 little specs. And we'll go into how many we should see and all that too. And then here's what your manufacturer's phantom will look like. Okay, so here's what we should be seeing. So keep in mind the slants of these fibers here. So we can see 1, 2, 3, 4, 5, 6. We've got 6 fibers. 1, 2, 3, 4, 5 speck groups with 6 little specks in each group. And then 1, 2, 3, 4, 5 masses. This is on the traditional ACR, the little square phantom. Now, if you use the manufacturer's phantom, then they go straight across and they are 6 and 6 and 6. So that's something that you will need to remember. This is 6, 5, 5, and this is 6, 6, 6. So that's probably an easy one to remember, whereas this one, you just got to remember the second two, or there's only 5 groups. Okay, so when scoring your objects, like I said, the way I said that wouldn't pass if that was really all I was seeing. You score each object as 1 point, a half a point, or a 0. However, you do have to stop counting if you do not give a full point. So if you only score a half a point or a 0, and then you see like the next mass is completely clear, you can't count that, because you are counting in order from left to right, top to bottom. And we'll do a couple of these just, to help out. But you do have to stop counting if you have not given a full point. You just can't even count anything after that. So do not count subsequent objects, even if they are visible. So for your fibers, that's those just lines that on the traditional have 6 lines going across, and they slant opposite every time. So to count it as a full point, you have to see the full length of that fiber. So it will be 8 to 10 millimeters that you will be able to visualize. The location has to be correct, so you have to pretty much know where those fibers are supposed to be, which they're...
Are they always at the top?
Yep, and they're evenly spaced out. But if you ever see anything that looks off, like in a different, then it could be something on your image. You could have an artifact, you could have an artifact somewhere on your machine that needs to be corrected. So just make sure that all those fibers are in the right place, because if you see a line that's kind of off, then that could be, that could be something that's not supposed to be there. And then that the orientation of the fiber is correct. So the way that they slant oppositely each time, just make sure that all that is correct. So that's how you count as a full point. And then there is allowed to be a little tiny break, but that's just basically, our vision, what we see. So a little tiny break is allowed as long as it's less than the width of the fiber. So by the width, I mean the little skinny part of the line. So the break will be very tiny. And then you can score a half a point if at least half of the length of the fiber, so about 5 millimeters, is visible. Again, that the location of the fiber is correct, so that we know that that fiber is indeed a fiber and not some kind of artifact. And that the orientation of the fiber is correct, so that they slant in the right direction, the correct directions. And again, 1 break is allowed, but it has to be less than the width of the fiber. And we're going to look again, because, well, I'll go back up to this one, see how the fibers are different widths. So you have this really dense one, and then they get less and less dense until, they get really hard to visualize. So if there's a break, it could be a little bit of a thicker, a little bit of a bigger break on this, because this one's thicker, whereas on this, the break would just be the width of that fiber, which is so tiny. Okay, so scoring your spec groups. You can give a full point if you see 4 or more of those little specks, because remember there are 6 little dots in each group. So you have to see at least 4 of those dots, and you can score a full point. And then the location of those specks have to be correct. So you know that they're sort of, I don't know if you would call it a flower shape or what you would call those little group of specks, but it has that 1 dot in the middle and then the 5 around it. So just make sure that the location of each of those specks is correct. So you just have to know that you just have to know the pattern of the specks, because if you see a little dot that's kind of off, then that could be an artifact as well, and that artifact could be mistaken as a calcification if you let that slide, and if you score that and it wasn't supposed to be scored. And then you can score a half a point if you see 2 or 3 of those little specks in each of that in that particular speck group that you're scoring. Again, the location of the specks have to be correct. So you just have to know the normal patterns, because that way you know if something's off, if you see a little speck somewhere that doesn't belong. And then your masses. Masses are kind of the most difficult in my opinion, because you have to really look at the borders and everything for your masses. So to score a full point on the masses, the border should be continuous and generally circular. So 3/4 of that border should be visible. And again, you just need to know the normal location so that you'll know when something is off. If you see a mass that kind of looks elsewhere, then it's probably an artifact. You can score a half a point if the border is not continuous or generally circular for more than 1/2 and less than 3/4 of the border is visible. So basically, if you see a complete circle, you can score it a full point. If you see 3/4 of a circle, you can still give it a full point. So anything less than 3/4, but over 1/2, you can get half a point. Anything less than a half, that's just a 0. So here's one right here. So we have, let's see, I'm gonna put on my readers. So we have here 1, 2, 3, 4, and I can see 5. So this one is hidden because and this is a little 4 centimeter acrylic disc that that's on top of a mass here. Some facilities will use this little disc to make sure, and they'll just kind of move it around on different images. So we're not going to really focus on that right now, because that's not something that's in any of this information in this manual. But there would be a little fiber underneath there, which we can't see, so we obviously can't score. So we have 1, 2, 3, 4, 5 out of the 6, so that gets 5 points.
Okay.
Moving to our spec groups, I can see 1, 2, 3, 4, 5, 6 here, so that gets a full point. I can see 1, 2, 3, 4, 5, 6 here, that gets a full point. I can see 1, 2, 3, 4, 5, 6 here, so that's a full point. Then moving over here, I actually can see. I don't know if you can, but I can see 1, 2, 3, 4, and 5. I do not see one over here on my monitor.
So if you don't see all of the specks, it won't count as a full point.
Correct. If you don't see at least what was it?
5.
At least 2 to 3 for half a point, and 4 to 6 for the full
point. Okay.
So this would, in my opinion, on my monitor, this would still get a full point because I can see 5 of those specks.
Okay.
Now moving on to this group that's supposed to be here, I don't see a thing. I don't see not one little speck, so there's no point for that. Now, if I could only see 3 here, 1, 2, 3, then this would only get half a point. But I can see 5, so I would score it another full point. So these fibers would get 1, 2, 3, 4 points from me. 1, 2, 3, 4. Which is why we had that discussion board on whether you think one person should do it or whether you think, it should be collaborative for people to do the QC. But, from one week to the next, it may look like your equipment is, altered if, like, you're seeing something different than me, which you probably are. Did you see the same things that I saw whenever I was going through?
Yeah.
Okay.
I don't see anything in that last group, though, if it were to speak, so I don't see anything in that last one.
Okay, neither do I. So, yep. And then when we do our masses, this looks like a complete circle to me. So it's going to get a full point. this looks like a complete circle to me, so it's going to get a full point. Same with this. I may see a little tiny bit of a break right here where it's a little fainter on the kind of top left-ish, but it's still, the border is generally circular, and it's more than 3/4 in on my monitor. So I'm going to count that as a full one. And then this little one right here, I would say that's also generally circular. It looks like it's a little faint in the right up here part, but I still think it's more than 3/4 on my monitor. So I would give that one a half a point. Going down to this last one. So when I look at it on my PowerPoint, and then I go back over here and look at it on the screen where I'm sharing it with you, I'm seeing two different things. Like over here, I can see a mass on my actual PowerPoint on my monitor that I'm sharing with you. But when I look at the Blackboard part that is your image, I'm not seeing it. But I see about, I think about a half. It's sort of like a moon shape on my monitor here. So I would probably give that a half a point. So 1, 2, 3, 4.5 is what I would score that one. Does that make sense?
Yes, ma'am.
All right, let's do another one. All right, that looks the same. That's the same one. Let's go to this one. So this one's really clear. I can see everything.
You can see that one good.
Yeah, this one gets perfect points for me. So 1, 2, 3, 4, 5, 6 fibers. I see all 6 dots. I see all 6 dots. I see all 6, 6, 6, 1, 2, 3, 4, 5. That gets a full 5 points. All of these are complete circles, and I would give all those a 5 points. Moving on to this one. So this one I can't see a whole lot. I see 1, 2, 3, and barely, vaguely
See
about
4.
half of, you see full 4?
No,
okay.
I can see half of it.
I can see half of it. So I would give that 4.5, whereas you may give it 5. So if you know, I'm not going to grade it as wrong when you do this QC. But again, once we get in the setting, that's where it matters. That's where, you know, your eyes have to, and that's why you'll use the same monitor. You know, obviously you'll use the same acquisition monitor every single time. So your monitors won't vary once you're in the clinical setting, whereas yours and mine do. So as far as grading, I'm going to be lenient because I can justify what you tell me. Whereas in the clinical setting, in the clinical setting, you know, your testing is just going to have to look basically the same each time. If it's off, then there's probably something wrong with your equipment. Moving on to the specs. I cannot see a lot of specs on this one. In fact,
I see the first one. I see the first one clear. I can barely see some of the second one, but not the whole full thing.
Yeah, I think that's all I see too. So this wouldn't pass. We would have to call in, you know, the clinical engineers to fix our equipment, and then we'd have to do this all over again before we could even do a patient.
How long does QC normally take?
We used to only schedule it for about 30 minutes in the morning. So
and they do that before they do that before they do the patients. They do that first thing before they do the patients.
Yep, exactly. And all it is just one image of this particular phantom, and then you go in and you score it and put it in your documentation. Because when your facility gets inspected, they're going to look through that with a fine-tooth comb and make sure that you've done all your QC and that nothing's kind of been not passing. Because if this hasn't passed and you still went and imaged patients, then you're not giving them the best quality images that they should be getting.
Right.
And then moving on to the masses, I do see 1, 2, 3, I think
I don't
that's,
see
I
anything at
think that
the
was,
end.
I don't
I
either.
can see it, but
I
it's
would
very
count that
faint.
as 4. I see a little faint something too, but I don't even think I would count it. I don't even think I would
I
count
don't
it as
see
a
a
half
full
a
circle.
point. Yeah, I don't either. So that one I would only count as 4, and you may see a half, whereas I don't see anything. And so there's that. And then, so this is the little disc that I was talking about. It's just for contrast measurement purposes. I don't think we have anything in our assignments about it, and I don't think it's in this manual either. Sorry, I'm starting to get choked. So anyways, on this one, I can see a lot of fibers though. So I can see fibers 1, 2, 3, 4, 5, and I think I can see more than a half. I can see about 3/4, so I would count that as a full point. So I would count that as 6. And then moving on to my specks, I can see 6 little specks here, 6 little specks here, 6 little specks
There.
here. And I, on mine, can see
I see 4 of them.
I can see at least 4 on this one. 1, 2, 3, and then this middle one I can see. I can't see the 2 bottom ones on mine. So I would still, 4 counts as a full. So I would count that as 1, 2, 3, 4.
Uh-huh.
And then this is the disc. So we start here with counting. So this is an actual fiber. 1, 2, 3, 4. And I can see this one. I think this one I can see pretty good. And I think it's more than 3/4. So I would go ahead and count that as a full point as well. So 1, 2, 3, 4, 5. So I think everything on here got a perfect score except for these specs, which only got 4 out of 5.
Right.
Still definitely passing. So here we go. And this is something you can, I mean, like I said, I'm recording this, plus you have it in your books and everything, but this is, I'm sure, this is something that you will probably be asked in some way, shape, or form on the exam. But in order for the phantom images to pass, the criteria is for the ACR digital mammography phantom, the new phantom that follows this manual from 2018. Fibers, you should see 2 or more. Spec groups, you should see 3 or more. And the masses, you should see 2 or more. So some of those that we looked at, even though it didn't seem like we were seeing a lot, they may have passed. The ones that we could just see 1 would not. And then here are the actual manufacturers criteria. So we have a Logic and Siemens separate from, GE, Fisher, Fuji. This is why I say most people probably are just using the
Traditional.
Yeah. So we have
because they're definitely not the same.
Right, exactly. So for that rectangular one where there's 6, 6, and 6, for these particular manufacturers, Logic and Siemens, they're going to require 5, 4, and 4. Whereas using the same phantom, GE, Fisher, and Fuji are requiring 4, 3, and 3. So all of this is something that I don't know an easy way to remember it other than just memorizing it somehow. It's just going to be you're just going to have to put that in your memory, because I've tried working on some kind of mnemonic or something that would help me remember these, but you just have to put it in. That's one of those things that you're just going to have to memorize before you go into that exam. And then once you're in the clinical setting, you'll have your routine anyways, so you'll know which one of these are using, so you'll probably just dump the rest of the others. Okay, so here we go. These are just some more examples. So we're looking at this, we're just looking at fibers here. So for this one, I see 1, 2, 3, and I would call that a half. I would say 3.5.
Mm-hmm.
For these fibers, 1, 2, 3, 4.5.
And a half.
Mm-hmm. Here I see 1, 2, 3. That break is wider than the width because this is a skinny little fiber and that break is it's bigger than the width. So I would not count that as a full, but you still can count that as a half because I think this down here is about a half. So now that we've counted that as a half, I cannot come down here and count this one at all because remember, we have to stop. If we don't get a full point, we just stop counting completely. So even though I see a full one here, this is not 1, 2, 3, 4.5. It's 1, 2, 3.5, and we stop. So this is just nothing.
Okay.
Good on that?
Mm-hmm.
And then this bottom right, no tricks here, just 1, 2, 3, 4, 5, 6. I see them all.
Mm-hmm.
For spec scoring, so we have, I see all 6 here, all 6 here, all 6 here, and then the next one has 3, so that's 1, 2, 3.5. 1, 2, 3, 4, because it's more than 4. I see 5 here, so that still counts as a full point. So 1, 2, 3, 4, and then this has 3, so that counts as a half. So that's 4.5 spec groups that I see. Moving down to the bottom left, 1, 2, 3.5, and then you move on to this 1, 2, 3, 4, 5. This would get a full point if I had not just scored a half here because I have to stop. So again, 1, 2, 3.5, and stop.
Right.
That's like
so you wouldn't count that. So 1, 2, 3. So that would be 3.5.
Mm-hmm. And then, like I say, even though I see
A
5
full
specs
one.
on that last. Yep, I see 5 specs on that last one, but I cannot count it because I just gave a half a point. So I
To the one before that.
Yep, on the one before that. This one right here, 1, 2, 3. That only got a half a point, so I stop there.
Okay.
Stop counting. I don't move on. And same for these. So scoring just masses here. Sorry. 1, 2, 3. Those are all full circles.
Mm-hmm.
Here, 1, 2, 3. And would you say that's a half or more?
Yeah.
I would too. So I would count that as 3.5. Here I see 1, 2, 3. And would you say that's 3/4 or more?
Yeah.
I would too. So if it's 3/4 or more, we can count it as a complete one. So 1, 2, 3. If we count that as a 4, then we can move on to this one and count it as 5. So we're seeing 5. Now, if I had only counted this as a half a point because I thought it was less than 3/4, then I wouldn't count that one at all.
Okay.
Stop. All right, here's another example of a mass. 1, 2, 3, and that is definitely more than 3/4, so that counts also. Moving over to this one, 1, 2. I would say that's 3/4, or I would say that's about 3/4. So I would still count that as maybe that's a tough one. I would count that as a full one, but I don't know if you would. But like I say, that's why it's sort of subjective. But if you did it on your assignment, I would allow that. I would say, okay, she's right. You can't really tell whether that's 3/4 or more for sure or not. Moving on to this last one, I do see 1, 2, 3 because that looks generally circular, and it looks like it's almost in a full shape. So just as long as you have some sort of background density difference, and I am seeing a density difference, which makes this look like I can visualize a full circle here, even though there's some, wider areas. It's still
right. It's not as full.
Right.
Or not as dark.
Mm-hmm. All right, so moving on. So, like I said, minimum frequency for your phantom image quality is weekly, and always know that your corrective action is going to be before clinical use. So if you've got a waiting room full of patients out there, and you just finished your QC and your phantom image didn't pass, then you have to go out there and tell all those patients that we have to reschedule for another day, because we got to call them in here to fix our machine and make sure that we're seeing the bare minimum of what we need to see in that breast.
Right.
All right. So again, make sure that you know the purpose of your test, why we're doing it, the frequency, how often we're doing it, the materials that you use, which in this case is your phantom and the large paddle, and then your step-by-step procedure, which is, line your phantom up at the chest wall border of your detector, compress to 4.2 centimeters, and then which is usually about 12 pounds, which we'll talk about that when we do the compression thickness and all that. But anyways, just know your step-by-step procedure. And then this is what it looks like when you go to log it. And so you'll just, kind of put how many of each that you saw.
Is that how the paper looks when you score it?
Yes. So you'll do your fiber scores, your spec scores, and everything down here. And then you've got your dates each week. So just remember, every week you'll see a different one. Hopefully these don't change very much, but if they do, it should be gradual, and then obviously, pass or fail. And then they have, the scoring down here just to remind, as a little reminder. All right. All right, so the next one we're going to talk about is the compression thickness indicator. And this is to ensure that the compression thickness indicates the correct degree of compression. So basically that your numbers, your digital numbers that you're looking at on your machine are in fact what they're supposed to be. They're correct, that your numbers aren't off. So you do this monthly, or if there's new equipment, we do all of these. So that's always going to be an answer if that's ever asked to you. Your frequency is monthly on installation of new equipment, and whenever anything is expected to be incorrect. So the frequency is always going to be like your phantom image was weekly or on installation, or whenever there's a problem. This is monthly or on installation or whenever there's a problem. So if you're ever asked that, then you know that those two things are always going to be part of your answer. So again, you need to know your equipment. So you can use any kind of object as a little phantom just to make sure, but you're going to measure that. Like some will use the little roll of tape. So if you use your little roll of tape and you have to actually measure it in real life, like use a ruler or tape measure or whatever, and say that is a 2-inch roll of tape, then you know that when you compress your machine, that your numbers that show up digitally on that machine should say 2 inches. So that's basically what this test is for. So you're going to center the phantom, whichever little phantom you choose. In this case, we chose a 2-inch roll of medical tape. You're going to center it on your detector, aligned again with the chest wall edge. So everything kind of gets out there towards the chest wall, not deep on that digital image receptor. Because once a breast is on there, you know that the chest wall is thicker. So that's the part that you really want to focus on. Whereas as the breast goes more in towards the back of that machine, that's where your nipple and everything's getting smaller. So we always kind of put everything at the chest wall edge because that's the thickest part. Center the phantom on the detector aligned to the chest wall edge. Compress the phantom using spot compression paddle and record the thickness. You still have that same paddle on there. The compression should be 10 to 15 pounds, which equates to 4.4 to 6.7 decanewtons. So every pound, I think it's 2.248, I believe, decanewtons equals 1 pound. And then what you're going to do is you're going to subtract the actual measured thickness from the thickness of the phantom, just to make sure, and you're going to record the results and make sure that they are the same. If they are not the same, they should be accurate to within plus or minus half a centimeter. So if your tape measure says it's 2, what did we say it was? If it's a 2-inch roll of tape and you're coming up with, 0.5 centimeters less, that's okay. So corrective action should be taken within 30 days. So in this case, you don't have to go cancel all your patients because you still have 30 days to make that fix. So always know your corrective actions, in addition to, your purpose, your frequency, and your step-by-step process. And then you're going to record it on here. And since we said this one is your frequency is monthly, that's why this has months here instead of weeks. All right, so visual checklist. This is pretty simple stuff. This is just basically you're looking at everything. You're making sure that your paddles are working, your compression paddles. You're going to make sure there are no cracks in anything. You're going to make sure all your lights work, collimator lights, which I don't know if we talked about this in one of the chapters, but remember your collimation is the size of your paddle. You don't do like extra collimation like we do in X-ray. We leave that open. Paddle controls your collimation, but you do still have a light. So you still have that light that you need to make sure is working. So that's part of your visual checklist, ensuring that indicator lights, detents, mechanical locks, and everything is in working order. So locks meaning you can set your locks to whether once you take that image, the compression is going to come off that patient, or you can set it to where once you take that image, your patient is still compressed because now you have to move on to do like a 3D image or something. So just make sure that your locks are working based on whether you have it locked or unlocked. And then your frequency is going to be monthly after service and before clinical use or upon installation of new equipment. And the equipment that you need is your visual checklist form. And I probably should have added on here that, just to make sure that you have all it's basically all equipment. So I guess you just need your visual checklist form. Another thing you should check is in mammo, we are standing in the room and we're kind of behind that console with that lead. We're not in a separate room, kind of like we are in X-ray. We're just sort of behind that lead window. And a lot of times you'll see mammographers like decorate it for the different holidays and stuff. Technically, that is supposed to be completely clear because that's part of our visual check, is to make sure that we can see straight through that, in case anything happens to our patient. So that's just kind of part of our just making sure we can see through that lead window as well. And then critical corrective action should be taking place before clinical use. So you just clean whatever is wrong. You just have to, clean if there's something on your paddle. You have a face shield. If that's cracked, you just need to make sure you're not using a cracked face shield. All locks must work. And then non-critical corrective action within 30 days. And then here is what it will look like whenever you go through and just kind of in January, you look and make sure that your mag stands and paddles are free from dust. Your room is free from dust. Cleaning and solution is available. It talks about all your locks and your lights and everything. So basically that's just as visual. It's just you looking and making sure everything looks good. All right. Make sure that the acquisition workstation and the radiologist's review station is clean and free from fingerprints, dust, or any other artifacts that could interfere with viewing or interpreting the clinical information. Tests in the manual also address the calibration of brightness and contrast settings appropriate for both monitors. So you'll do a workstation monitor, you look at some patterns on there and just kind of make sure that you see density differences. You'll do that on both yours as well as the radiologist. As you know, the acquisition monitor is the technologist monitor. The information that the technologist assesses, positioning, compression, contrast, patient motion, those are all displayed on the acquisition monitor. It's not used for interpretation. So our monitors are different. We may not see something that the radiologist can see. So there may be times that the radiologist may contact you and ask you to repeat something because it could be something that you didn't realize was there, and they saw it, like an artifact or something that you didn't see on your monitor. Our monitors are not used for interpretation for that purpose. It should satisfy similar monitor requirements to the radiologist monitor, and therefore both displays should be similar. But again, ours is not as strong as theirs. It doesn't have all the density differences. So the purpose of the acquisition workstation monitor is to ensure that the monitors are clean and free of dust, fingerprints, other marks that may interfere with clinical information, ensure that the monitors are calibrated correctly and the brightness and contrast settings are appropriate. And this is done monthly or again after service or new equipment. So basically this is sort of common sense stuff. You just visibly inspect the monitor, wipe away any foreign material, use a cloth. After it dries, recheck and make sure you don't need to repeat anything. Some monitors have built-in automatic calibration features and digital test patterns that can be used in testing. If the monitor has those calibration tests, they do need to be performed. Not all are still doing that, those different patterns where you see all the different checkered patterns on the screen. ACR recommends the use of the American Association of Physicists in Medicine Task Group, QC test pattern, and calibration QC test. However, if that is not available, the Society of Motion Picture and Television Engineers, the SMPTE, you've probably heard of the SMPTE test pattern, or other test patterns can be used. And this is the one that's preferred, the one that we just talked about. ACR recommends the use of this AAPM TG18, and that's what it looks like. So it looks like that in a clinical setting, and you just kind of look at the different densities. And then the SMPTE pattern is generally the pattern used by the QC technologist, and SMPTE stands for Society of Motion Picture and Television Engineers. Again, it looks like that. There's the first one.
There's about 73 or 4.
And there's that one. So, again, you're supposed to know all your equipment for each, the purpose of the test, frequency, materials, and step-by-step procedures. So, if using any of these test patterns, you'll just reduce the lighting in your room and evaluate the following areas. So 0 to 5% contrast boxes should be visible. 95% to 100% contrast boxes should be visible. And the line pair images at the center and 4 corners should be visible and distinguishable. And then if using the monitor automatic test, you just open the monitor's QC program, review the results, and verify that everything has passed. It will tell you whether it has passed. Any large significant blemish that interferes with the visualization or QC of images is a failure. All failures need to be corrected within 30 days. All monitor condition failures, blemishes, anything interfering with the visualization of the image must be corrected before clinical use. Again, correct within 30 days. And then here's what it's going to look like in the clinical setting whenever you go to record everything. Then moving on to the radiologist workstation. So that, again, this is usually done real early in the morning before the radiologist gets there. So we'll go in and ensure that their workstation is clean, free from dust, fingerprints, other marks. So basically the same procedure. We're just going over to their monitor and doing that on theirs. Monthly after relevant service and upon installation. So basically the same stuff. Dry, soft, lint-free cloth or clean tissue recommended by the manufacturer. And then the test pattern of the American Association of Physicists in Medicine, the AAPM, is the one that's preferred, and then we use the SEMTI if that's not available. Again, visually inspect and wipe anything. Reduce the lighting in your room. Again, just like you did with our workstation, with the acquisition workstation, you're going to do the exact same thing. And the contrast is going to be exactly the same. 0 to 5% or the 95 to 100% boxes. There's two different boxes on these patterns that you just need to make sure that you can visualize, and your line pair images at the center and four corners. So it's the same on the radiologist as it is on ours. And then again, just make sure that you clean them if it's not clean. And then there's that. So it's going to be you're just going to log it all in there. Repeat analysis. So the repeat analysis is done quarterly. Most updated equipment kind of just does this on their own now. We don't have to do, we used to have to little document and count repeats and everything, especially when it was filmed. But now most of our machines will just log that for us. It's kind of automatic. So it's real easy now. But just so you know, for testing and registry purposes, make sure that you know the repeat analysis steps and all that sort of thing. So it's done quarterly, but could be done more often. You need a patient volume of at least 250 in order to do the math of the analysis. What you'll do is track the total number of patient exposures during your analysis. So during your quarterly process, you'll track the total number of patient exposures. Then you'll count all of the repeated exposures. These include images sent. So you're counting repeats. You're not just counting the ones that were thrown away. You're counting everything that was repeated. And then you'll figure the individual cause and view percentages. So if you find that the cause is, your technologist just isn't doing good images, then that's going to be, that's going to be a problem that's going to cause for some kind of changes. But if it's just based on, you had a student that you were training.
Answer that. Tell her I'll call her back in a minute.
Okay. And then you'll figure your overall reject and repeat rates. So rejects and repeat rates are not the same. Rejects means you threw everything away. Repeats means you just repeated. You may have kept that because you may have had an image that you still liked. In X-ray, sometimes it's like, oh, we'll send both. So even though it's a repeat, it doesn't mean it's a reject. You may have kept it instead, because there may have been some diagnostic information out there. So repeats and rejects are not always the same. Your repeat rate should be 2% or less, but if your physicist or your radiologist allows 5%, then that's fine too. But they will determine that based on what's going on in your facility at the time. Like I just mentioned, maybe you have a student that you're training, so you're gonna obviously have more repeats than a seasoned technologist. So they may, switch it up and allow you to have up to a 5% repeat rate. And then they should not vary by more than 2% of the previous rate. So you should not see big, huge changes, because that would signify a problem. And then we have some calculations on here. I think you have a little bit of math on this. in your assignment. So use this when you do that QC testing assignment. You have two math problems on there. But again, in the current facilities, the system is doing this for you now. We don't even have to calculate most of this anymore. But this is how you do it. So your repeat and your rejects are both on here. Repeat is your total repeats divided by your total exposures times 100. So if you have, and this is just me doing some math, that might help you later if you go back and look. If you have 4,092 films used, and then you have 83 repeats, then you just use this formula here. So it's 83 divided by 4,092 times 100. This has a 2.03% repeat rate. This down here, this reject rate is reject rate equals total rejects divided by total exposures times 100. So say you have the same 4,092 total films. You had 90 rejects, throwaways. Then it's 90 divided by that 4,092 times 100, and now you have a 2.2% reject rate. So your repeat and rejects may be different because some you get rid of completely, and some you say because they may have diagnostic value. So you good on the difference between repeat and reject?
Yes, ma'am.
Okay. Repeats will include your rejects, but your rejects are just repeats.
Or just rejects.
Yes. All right. So you'll do the minimum frequency is as needed, but as we said, it has to be done quarterly. And then your corrective action is within 30 days of repeats because you're going to have to, they may even send you to do some extra CEUs or get some extra training and that sort of thing so that you do have less repeats. Bless you.
Thank you.
And then, of course, this is where you'll record it. But your machines, you may just allow you to print it now since they do their own on the more traditional ones. I'm sorry, the more recent ones. Okay, viewing conditions. Your purpose is to ensure that the view boxes and viewing conditions are optimized and maintained at optimum level. If prior or outside clinical films are not viewed on view boxes, this test is not applicable. So you'll do this monthly after relevant service and upon installation before clinical use. Equipment is a cleaner recommended by view box manufacturers, soft towels. The procedure is clean surfaces using the recommended cleaner, ensuring that all marks have been removed. Corrective action should be taken place before clinical images are viewed on the view box. We don't see view boxes anymore that I'm aware of, but I'm positive that they don't have them in Lumberton. But you never know. You might have to go to a facility where they still use view boxes, especially if their comparisons are on films that haven't been digitized yet. Then you might have a facility that uses the view boxes, but that will not be common. So compression force, this is different than our compression thickness indicator that we did. Our compression thickness indicator that we did, remember, would have been where we used the little phantom, which in my case, I used a little roll of tape that was 2 inches, and then made sure that that roll of tape that was 2 inches, that our indicator showed 2 inches so that it wasn't off within more than half a centimeter. So in this case, compression force is a little bit different. So compression force is to ensure that the mammography system can provide adequate compression in both manual fine adjustments, which is when you use the little hand roller and make the compression paddle move up or down, or whether you use the power drive, which is when you put your foot and let it move the paddle up and down, which is a little faster. When you use your hand, you can kind of just do little tiny adjustments instead of just using the power drive. So this is to ensure that the system can provide adequate compression in both the manual fine adjustment and also the hands-free power adjustment. That the equipment does not allow too much compression to be applied when used in power drive mode, and that adequate compression can be maintained throughout image acquisition. So how you do the compression force. This will be done every 6 months, so semi-annual, whenever reduced, excessive, or unstable compression is suspected and upon installation of new equipment. You'll use, the towels are just used so that you don't damage any equipment. So you'll see probably like little hand towels or face towels will be just put underneath an actual bathroom scale. And you'll put one towel placed on top of the scale and the other one on the bottom. That way you're protecting the detector as well as your compression paddle. The scale is placed on the detector, and then you use the initial power force and apply compression. So that's your foot pedal to apply that compression. The minimum force during initial manual fine adjustment mode should be 25 pounds, which equates to about 111 newtons. The maximum is 45. Now, this is something that you'll be asked over and over. I wouldn't be surprised if that's something that was on your registry. So remember that 25 to 45 pounds.
25 to 45 pounds.
That's your minimum and your maximum. So when you compress, you've got that bathroom scale sitting, a literal bathroom scale sitting on your detector. And when you compress, you see that scale, you'll actually see the weight. So that is actual weight of your compression. So it should be able to go between 25 and 45. This compression should hold for the average length of time for one projection exposure. That used to be about 12 seconds. I think it's gone a little bit less. It was 12 seconds whenever I was doing 2D and 3D. But I think they're synthesizing more stuff so that the 3D includes the 2D. So 12 seconds is probably a little more than the average length now. But anyways, the compression should hold for the average length of time for one projection exposure. So that's just the amount of time that you need to know, one projection exposure. And then corrective action should be taken before clinical use, because you do not want to compress a breast too much and hurt your patient. And you don't want to do too little to where you don't have a good diagnostic image.
Right.
So your corrective action is going to be before clinical use. If something is wrong with this 25 to 45 pounds, then again, you need to reschedule your patients and get this taken care of. And then again, there's just the documentation. Manufacturer detector calibration. This is to detect and automatically correct equipment problems, especially related to digital detector performance. This may include compensating for dead or over-responding pixels, structured or other noise, nonlinear response, and other technical performance parameters. The frequency, equipment, and procedure is specified by the manufacturer, and you'll also do it upon installation. Again, documentation. And then here is a list of the technologist tests as it appears in the manual that we're using. So you can use this as your help for when your frequencies are due. And then your correct action, whether it's for clinical use or whether you can wait 30 days. So this is an important document that you should probably try to memorize most of those as well before you get your registry. And again, that is in your, I think it's in the 20s or 30s page in the in your ACR. If you will find it right now. Anyways, it's in your ACR digital mammography manual.
I remember seeing that in one of them videos that you've uploaded.
Oh yeah. So make sure you have a copy of this. And you know, like I say, it'll be in this video as well once I upload it, but it's also in this book. And I think I just found it on page 37. And then your medical physicist tests, we're not going to focus a lot on that for as far as QT testing purposes in this module that we're working on now. But you did do some just sort of quizzes and that sort of thing just to know what the medical physicist is required to do. He has the most, I guess, his responsibilities are a lot higher than ours, if that makes sense.
Right.
All right, so before a facility, QC technologists may start using the procedures in the ACR digital mammography QC manual for the first time on a unit. The medical physicist must first conduct an annual survey of the equipment. They'll use that ACR DM Phantom. It's important to provide testing techniques and procedures for the QC technologists to use during routine QC. After this is done, the technologist may start performing routine QC using the ACR digital mammography QC manual. Here is what the physicist is responsible for. So he's basically responsible for all the equipment before the radiologist and us. So he's responsible for mammographic equipment evaluation, collimation assessment, system resolution tests, low contrast performance test, automatic exposure control, artifact evaluation, phantom image quality, KVP accuracy, beam quality assessment, average glandular dose, room illuminance, evaluation of the technologist QC program. So that's why I say he's making sure that we are qualified. He is checking the application of compression, the compression paddle alignment, and the acquisition and radiologist interpretation workstation QC. So he's going to oversee all of us, us and the radiologists. The mammographic equipment evaluation is to ensure that all mammography equipment meets the FDA's final rule for mammography and complies with MEE only required tests. As part of the MEE of new units after relevant service and after component replacement. So mammography equipment evaluation.
What happened?
Oh. All right, we are almost done. So the collimation assessment is to ensure that the X-ray field aligns with the light field and the collimator allows full coverage of the image receptor with no radiation beyond its edges. Do remember what I have in red here. The collimation assessment, remember I told you collimation is the size of the paddle. We do not collimate additional. So the X-ray field, the lighting, and the paddle and the collimator light, everything should cover the image receptor not beyond the edges within 2% of the source to image distance. So just remember
I think that was on one of them quizzes.
Probably, because that's an important one that's probably going to be on the registry as well. And then ensure that the chest wall edge of compression paddle aligns with the chest wall of the image receptor within 1% of the SID. So just kind of remember those two things. 2% for your X-ray field aligning with the light field in the collimator allows full coverage of the image receptor. 2% and chest wall edge of compression paddle 1%.
Okay.
If the pattern is too short, it will show on the image. The actual paddle will show on the image, and we don't want that. So as part of the mammography, what did I do? So as part of the mammography equipment examination of new units after relevant service and after component replacement. And then for 3D, as part of the MEE of new units and after relevant service and annually. And they use coins and pennies for that test. And here's what it looks like. Oh no, this is the spatial resolution. These are the little diamond things, and you'll see them in the clinical setting as well. To measure the limiting spatial resolution as an indicator of detector performances, this is as part as the MEE of new units or annually or after relevant service. So you will not do this. And then the modulation transfer function measurement. This is all stuff that we talked about in other modules. Signal to noise ratio, we talked about in the past modules. Contrast to noise ratio. And if you need any to go back on any of these, those are in the manual as well as in our textbook. AEC exposure controls, your flat field or artifact evaluation, phantom image quality, we just went over a lot of that, KVP accuracy and reproducibility. This is all the stuff that the physicist will do. Beam quality, average glandular dose, doses exceeding 3 milligrams must be corrected before clinical use. So 3 milligrams for clinical use.
3 milligrams.
And then they'll check the room luminance. They're going to make sure that the ACR recommends 20 to 45. And the physicist will make sure that your room has the correct lighting. Evaluation of the technologist QC program. They'll make sure that they're verifying that we are doing the correct QC. And then again, application of compression ensures adequate compression is applied uniformly over the entire breast for paddles that are designed to be flat and parallel to the breast support. So like we said, we have a thicker part at our chest wall than we do at like the nipple area. So the minimum automatic compression should not be less than 25 and never exceed 45 pounds. All units should have the hand-controlled compression device as well as that foot control. Make sure that everything is aligned. And again, you don't want it to be more than 1 centimeter at any point on the surface because then the compression paddle will show on your image. Again, he's going to check the acquisition workstation. All of this is just physicist. So we're focusing on the technologist stuff now. So we're kind of beyond that. So as far as taking that little test next, unless you have any questions for me.
I'm good, I think.
Okay. Well, I'll upload all of this, and of course, if you have any questions, you can email me, call me, whatever.
I'm gonna go. I'm gonna try to go get a physical. I'm gonna go get a physical done, and I got to go get a TB skin test done, and all of that.
Yeah, just upload that to the viewpoint screening, and like I said, and I will check with Christy over in Lumberton, and we'll kind of get a schedule ready because I go out May 23rd. Your last day is mid-May. I think May 5th or 9th or I don't know. But your last day is mid-May, and then I'm here another week after. So if you need me, I am still here until May 23rd. After that, I'm gone the whole summer, and I don't come back until August 1st. So
when would the second semester start?
Second semester will start August. I come back August 1st. You come back August 13th. Let me look at it. It's a Monday in August. Yeah. August 18th.
August August the 18th.
You'll come back August the 18th, but that first week we'll still do online orientation stuff. So you won't go to clinic until like the 25th.
Okay.
And by then we should have everything worked out where all your onboarding is ready to roll and your schedule is set with 50 at UNC Health South.
What is y'all doing over there to her? Bring her here. Come here. Bring her here. I'm going to show you my little one. I don't know what her sister's over there doing to her. Hurting her feelings.
You gonna get that more control?
Oh my goodness, and y'all match. Oh,
look. Say hey. You gonna tell her hey?
Pretty.
Wave.
You match
wave. Say hey. So this is what keeps me busy.
Yes. Oh.
What happened? I don't know what happened. What did you hit, girl?
I can still see you. All right, let's see.
Quit. What are you doing?
What's her name? What's your name?
Her name's Ansley.
Oh.
Ansley
Now,
K.
Ansley K, you're so pretty. Oh, she's smiling.
And this is my other one.
Oh,
This is my other one, and she's 7.
You're a pretty girl too. I
She said,
have
you're a pretty girl too.
Yeah, I have granddaughters that are, well, I have one a little older than you, one a little younger. I have a 13, 11, and 5 granddaughters, and I have a 2-year-old grandson. So our girls are about the same.
I